Hi, psychology students, and welcome to the adventures of Ned the Neuron. Yes, we're going to talk about neurons today in chapter 2 because we want to kind of figure out how the neuron and the brain connect with psychology. So we're going to do a little bit of science this chapter. So let's take a look. There are some links on this PowerPoint, and if you can, I'd like you to try to click on those. If it's not available, don't worry about it, but I'll at least tell you what it's about at least. This link kind of is just an introduction into how amazing the brain is and how many neurons we have in our body as compared to a giraffe and an elephant and all that kind of stuff. So, all right, we're going to talk about neurons and neurotransmission. By the end of these notes, I would like you to be able to do 3 things. Number 1, tell us what is a neuron. Number 2, what does it do? And number 3, how does it do it? And we'll also be able to know the parts by the time we're done, guaranteed. So if you look at the definition, a neuron is a specialized cell that receives information and transmits it to other cells. Just a reminder as you're writing or typing here, remember you can pause this at any time or go ahead or behind to wherever you need to be in the notes. All right, let's take a look at the parts of the neuron. So we're going to fill in our document as well. So if you would look at your chapter packet that we do in class, I'd like you to write these in our diagram. So if you look at these little phalange looking things, these are called dendrites. And these are the things that bring in the signal into the neuron. They're the readers kind of, or the suckers, you might say. Then in here you have the soma or the cell body. That's another word we use for it, cell body. And within that cell, of course, you've learned this in science, you have a nucleus right in the middle. Then you'll see this long arm thing. This is called the axon. And this is what delivers the cell. And then on the very outside, we call that the myelin sheath. That's the protector. It protects the axon. And then over here, we have the terminal branches, and the little ends are called the terminal buttons, and those are the things that send the signal to the next neuron. So we bring the neuron in, and we send it out a different way. Now, in order to learn this, we are going to learn the neuron dance. I would play a song for you right now, but it's kind of hard to do with all this other stuff going on. So, and I know it sounds silly, but I am telling you, I've had college students send me emails and say, Mrs. Terpstra, you're never going to believe this. I aced my test in college because of the neuron dance. So I'm telling you these things will work. So first of all, I want you to use your left hand. Well, actually, I'll reverse it. So let's see here. So in this case, this hand right here is going to be your dendrite, and that is the hand that sucks in the message. So when we suck in the message, we're going to go like this. We're going to go. These are our dendrites. So make your dendrites. And then it's going to go into your cell body. Your cell body is your whole body. So we're going to shake our body. Okay? Then what do you suppose is our nucleus? That's our brain, right? So we're going to nod our nucleus. Okay? Then we've got our axon. This is our axon. So put your arm out. And then our shirt or our jacket is called the myelin sheath. That's the thing that protects our axon. And then here's our terminal branches. And our buttons go pew, 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 and they send out the message. So I want you to say that little sound. Go pew, pew, pew. All right, so the neuron dance goes like this. And then cell body, nucleus, axon, myelin sheath, terminal branches, terminal buttons. Pew, 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 pew. Do it with me. Ready? Dendrites, cell body, nucleus, axon, myelin sheath, terminal branches, terminal buttons, pew, 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 pew. And you have got the neuron dance. Good job. As we review the next couple of days, I'll name something, and it won't be in the same order, and you'll have to say which one is the axon or which one is the nucleus, and I guarantee you'll know those. Okay. Alrighty, on to the structure of a neuron. I know it sounds kind of silly, but this is actually a very easy video on YouTube that talks about the structure of a neuron. So if you can find that, I would recommend that you watch it. It basically just shows how the neuron sends the signal one way, and it goes from neuron to neuron and passes on. Okay? Here is actually a picture of a bunch of neurons under an electron microscope. So you can kind of see how it looks. Here's your dendrites. Here's your cell body. Here's the nucleus. And then, of course, you have your axon here. And then your terminal button sending it out to the next. So how does it work? I'm trying to get out of the way here a little bit. All right, so first of all, neurotransmission is a fancy name for two or more neurons that are communicating with each other. So for example, in this picture over here, there are 4 neurons that communicate. Some are larger than others, some are smaller, and you'll see how it's taking place. So here's neuron number 1, and it's sending this message down this axon here, and then your terminal buttons are sending over here to this dendrite here, sucking in this message into the cell body, nucleus, terminal buttons, and there's 3 and there's 4. You get the idea. Now, when it's being passed right over here from nucleus number 1 to nucleus number 2, or neuron number 1 to number 2, you'll see what's happening is it's basically doing what we call a synapse or a synaptic gap, where it's passing the chemical, that neurotransmitter, from this neuron to the next one. And then the new neuron is sucking it up like we did with our dance, okay? And we'll show you a closer up example of that in just a minute. Okay, so neurons actually stay at rest with their sodium ions. Now you'll notice it's color-coded. These are those purple dots on the outside of your neuron, okay? They are on the outside of the cell body. And then the potassium ions are on the inside, okay? So when neurons are active, they are no longer at rest. And what's happening is the sodium ions are going inside the neuron, and the potassium ions are rushing out. So it's kind of like this. It's going whoosh, whoosh, whoosh. And that's what's giving it its energy. And a chemical is basically what's causing that to happen. An electrical impulse is caused from that rushing in and out of the ions. We also call that depolarization. And that electrical impulse then races down that axon and then attacks or sends out to the next neuron. Once the electrical impulse reaches the terminal button, pew, 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 remember that? This right here, it triggers the vesicles that contain neurotransmitters, these chemicals right here, to move towards the bottom of the terminal button right here, and they're sent to that next receptor that sucks it in. Neurotransmitters are released from the terminal buttons, and they cross that tiny space between it and the next neuron, and that is called the synaptic gap. There's a couple of really cool videos here that let you see what actual neurons look like in real animation and all that fun stuff. So if you can't click on these, I'd recommend that you look at it and just type in on YouTube that title, and you'll get some of those examples. All right, so now let's talk about those neurotransmitters that are being sent from neuron to neuron in the synaptic gap. A neurotransmitter is a chemical messenger that carries signals between neurons as well as other cells in the body. These chemicals are released from the end of one neuron, and they cross the synapse to receptor sites in the next neuron as they're taken in. By the way, this is the start of day 2. We kind of did this in little parts, so just so you're aware of that. All right, let's take a look at some of the different neurotransmitters. Some of these you might recognize. The first one we have is called acetylcholine. Acetylcholine is often abbreviated as ACH. It is the most common neurotransmitter. Excuse me. It is located in both the central nervous system and the peripheral nervous system, the outsides of our body and our muscles. It was the very first neurotransmitter that was identified in the body in 1914. So what does it do? I tried to create pictures down below to remind you of each of these so you would remember them for their test. So acetylcholine helps with muscle movement, memory, and learning. So you can see why we have the big old learning down below, and we have a little gymnast down there. All that muscle memory with her on that balance beam is coming from those neurotransmitters, that acetylcholine transmitting between her neurons, and learning. In fact, learning about what you're doing right now in these notes is actually using acetylcholine. Just an interesting fact for you. You've maybe heard of sarin gas or a sarin gas attack. When that gas is released, it actually disrupts its ability to function, this acetylcholine, and often leads to death. So it's attacking the acetylcholine and not letting it through. So it's attacking those neurons. It's a nerve gas. Makes sense. Our next one is dopamine. Okay? Dopamine is generally involved in body movement. In fact, if you know somebody that has Parkinson's is basically a lack of dopamine in their system. What kind of symptoms do you see with someone who has dopamine or who has Parkinson's? Yeah, their hands will start to shake. They lose control of their muscles. So it makes sense then that their body movement would be affected. Okay. In the basal ganglia, we also are involving mood, sensory perception, and attention. But honestly, dopamine is most famous because it gives you pleasure. It's what gives you pleasure when you get first place at a tournament, or you get that rush of adrenaline, which is not adrenaline, but you get that rush of pleasure when you win a game or when you have sex or things like that. This is the pleasure neurotransmitter. So just kind of remember that dopamine is your pleasure neurotransmitter. If you've heard of people saying, I'm doping, that's why they're doing it, because they want that pleasure response. It's what it gives them. Our next one is epinephrine. Now, you might have heard of this one because when people actually have attacks, we might be using an EpiPen. You may have heard of that in school. That's what it is. It's epinephrine. So this is also known as adrenaline. This is what gives you that feeling of being revved up or on edge. It also is what gives you that fight or flight reaction when things happen. So when you jump out of an airplane, that's your adrenaline rush. That's epinephrine flowing through your neurons like crazy. If you've ever heard of stories where a family gets in a car accident and a mother like lifts a car off of her child, that's because she is getting a huge rush of epinephrine all over her body and probably doesn't even feel the fact that her leg is broken or something like that, or she's got internal wounds, because the adrenaline is just revving her up and getting her to try to save her child. So that's epinephrine. It's your adrenaline rush. The next one is serotonin. Serotonin is really interesting. It affects things like sleep, eating, mood, and pain regulation. Neurons which use serotonin are distributed through the brain, the stomach, and the spinal cord. This is basically a mood neurotransmitter. That's what it's most famous for. So, for example, people that suffer from depression are suffering from an imbalance of serotonin in their system. So quite often that's what they're trying to fix in that person. So think of that as the feeling groovy neurotransmitter affects your mood. Okay? The next one is glutamate. And glutamate is exciting. Got to think of glutamate as exciting. This is your excitatory transmitter. It plays a role in learning and memory. Now, too much of this stuff, because it is so exciting, it can cause seizures, which would make sense. This is also affected by Alzheimer's. So what do you see as symptoms with an Alzheimer's patient, if you know anybody that's had that? Yeah, that they start forgetting things, right? Eventually they forget their family, they forget a lot, right? So they actually have connected that to a malfunction of glutamate in their system, believe it or not. So just remember, this is your excitatory transmitter. Makes you excited. The next one is GABA. It's gamma aminobutyric acid, something similar to that anyway. GABA is the most important and the common inhibitory neurotransmitter, meaning inhibits. It takes down the walls so that you can just react without thinking. Okay. This stuff actually slows things down, makes you more sleepy, lessens your anxiety, because again, it's taking away all those walls that you have up to protect yourself. It stops the brain from becoming too overexcited. That's why you see this face over here. Now, what's scary about GABA, too much of this can cause hallucinations. And it's very easy to overdose on GABA. And actually, if you've heard of GHC, the rape drug, that's basically what they're doing. They're flooding the body with GABA because it's an inhibitory drug. So it again takes away this idea that I have to behave or I have to hold back, to the point that they can attack you and you don't remember the next day what you've done, or you realize, oh my gosh, why did I do that? Well, it's because they have put some of that in your drink or something like that. So, and we talked in class about how it's really cool now. They have napkins that can see if the drink has GHB in it, or little swizzle sticks that'll turn colors. Even nail polish. You can stick your nail in your drink and see if it's got GHB in it. So some really good things out there to prevent some of those rape drugs. This just kind of shows you how the three different areas kind of intermix and affect mood and anxiety. You've got the norepinephrine that's got your alertness and your energy. Your serotonin would be influencing like your obsessions and your compulsions. Your dopamine has to do with more attention, motivation, pleasure, and reward. And then you want to find a nice balance within those for your moods and your anxiety. Okay, some vocab for you. First of all, we have depolarization. This represents the signal being sent through the neuron, and it is the action potential. So basically, depolarization means that the action has happened. There's action through the neuron. Okay? The next one is the all or none principle, and it's very simple. The neuron either fires or it does not. It doesn't just fire a little bit, it doesn't fire partially. Once that message goes through the whole neuron with our arm and all that, sends out, it's already gone. There's no partial signal, it just fires. The other thing to know about the neuron, I think I mentioned this before, is called the direction of the action potential. It basically means that a neuron only fires one way. It comes in here and it sends out this way, pew, 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 but it doesn't come back the other way. It only goes one direction. One thing that's interesting, they have learned that neurons need a refractory period, meaning that it has to have time to reset itself. It's just like a computer. Sometimes it has to reset. So it gets a little bit of a motion there and it takes a quick break in between the different actions. But we're talking like, I can't even measure the time. It's so quick because our neurons are firing constantly every millisecond. We also have the official resting potential. This is kind of scientific terminology, but the sodium and potassium ions, remember when they go in and out, they are waiting at a threshold of negative 70 millivolts, waiting for a signal from the cell body nucleus. So it's kind of talking about how fast it's reading that message. Okay, the last thing we did here was we watched Crash Course in Psychology and kind of talked about what is a neuron. They've got a great little course on this, and we just basically filled in these questions. Some things to look for, because remember, Crash Course videos go very fast. I'm just going to warn you if you haven't seen these. So I want you to know what to look for. Number one, what happens with multiple sclerosis? Number two, explain everything psychological is biological. And this one will be first, actually, just so that you know. That one will probably be first. Number 3, why are some people sensitive to MSG? You've maybe heard of that in Chinese food, for example. And number 4, which group works like a text and which group works like a letter that you mail? Okay, so please watch that video and answer those questions. And then we have a really fun little assignment. You are going to be making your own example of a neuron in class, okay? So I want you to think of something that acts like a neuron and then try to figure out what parts would represent the parts of a neuron. So, for example, let me get one here. Let's see, I don't know if you can see this. Whoops. This student chose to do a drawing of Little Iron Man, and then you'll notice she labeled the parts of Iron Man and then explained why each represented each part of the neuron. There are 6 parts you're going to need to label. So, for example, Eva said the dendrite in this case is Jarvis. That's Tony Stark's computerized assistants, because they're the ones that he receives messages and information and gives it to Stark, that little computer inside his suit. Okay, so they're taking in the message. The axon, she said, would be the wires and cables in Stark's suit. Underneath the protective armor, it brings power to the different parts of the suit. The soma or cell body is actually Stark. He brought all of the suit together when he made it, so he would be the soma or cell body. The nucleus, in her case, I would have even said it could have been his brain, because you're looking for what runs the whole process. So it could be his brain. In her case, she said it was the arc reactor, which also makes sense because the arc reactor is what gives power to the suit, and the suit needs it in order to work. So great idea for her to use that. The myelin sheath was his metal armor because it obviously covers him and protects the suit. And then the terminal buttons, pew, 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 are actually the rockets in his suit. Power is released out of the rockets so that Stark can fly through the air. And then she labeled each of those on here. Isn't that a great example? So you're going to just take a piece of typing paper and draw it and then give us your examples, and it'll be turned in for 30 points. Okay? Now you can choose to do one example like this, or you can just do 6 separate pictures and then talk about what each of those represent and list those. She put hers on the back. But there's another option for you too, if you wanted to do that. Okay? Biggest thing I would tell you as I was helping people around the room is think about something that has a product in the end. And if you can start from the product at the end, then you can usually go backwards and figure out what parts equal what. That's probably the best way to go about it. Okay, I think there's an example for you right there. That is all for today. Have a great week, and we'll talk to you again later. Adios.